So it's not going to help you with long running queries, and it also doesn't help you if you don't know what query you want to send next until you see the results of the previous query. And it also doesn't help you unless you modify your application. But if you have the right use case, perhaps a web page that you're trying to render where you're going to run a whole bunch of queries against the database server and then look at all of those results and use that to generate HTML, in those kinds of use cases, this can really speed things up quite a bit. Then the last thing that I put into this category is a feature called asynchronous append. Append is a PostgreSQL executor node that is used when we need to concatenate the results of several different operations. So it is used, for example, when you're querying a partition table because we need to combine the results from all of the different partitions. Now, when you do set up a partition table, you can choose to use foreign tables as partitions. And if you do that, and then you query the partition root, you will be effectively querying all of those tables at once. And in previous releases, even though you were querying all of those different foreign tables, which might reside on different servers, the actual SQL queries that were sent to those foreign servers were sent one at a time. So we would send a query to the first server, get all the results back, then send a query to the next server, get all of those results back, and so forth and so on. And now with this feature, we can send queries to multiple servers at the same time, and we can just see which results come back the quickest. So this can really speed up queries of a certain type. If you have this usage pattern, basically it now behaves the way that you would expect it to behave, with all of the queries running simultaneously instead of what previous releases did, where the queries ran one after another. So that's pretty cool.
Yeah, I'm looking at this item, I'm thinking, people look at that like, wow, what a snore. Like, this thing is really not, sounds like, why is it here, right? Why, it's got this append node and it's got all this internal stuff. What good is this? Well, this is actually one of the ones I'm most excited about, because for the past couple of years, we've been sort of progressing toward a sharding option for Postgres. And that sharding option is made up of three pieces, really: the partitioning code, and the foreign data wrappers, and then the sort of push down capability that we've been adding to foreign data wrappers over the past couple of years. And one of the big missing pieces was the ability to run on multiple shards or multiple foreign servers. So the typical architecture we hope in the future would be one central server, a whole bunch of partitions. Each partition is actually a foreign link to a foreign server. And now you run a query and it parallel in Postgres 14 runs all of these queries, foreign data wrapper queries, to the shards in parallel. And you get the results back, you aggregate them, and you return them to the user. So this was a big wait for us, having this. I'm really excited once we get it into production. I'd love to get some people sort of benchmarking this thing to see what can be accomplished, because for very high write volumes, a single server is usually a bottleneck. And the idea here is that with sharding, you're going to be able to use the partitioning and the foreign data wrappers and the push down to effectively create a sharded version of Postgres that can handle higher number of writes than you could for a single server.
Because you've been working on this concept of sharding in general using foreign data wrappers for many years on and off, because you and I have had discussions over dinner and at conferences and things before now.
Yeah, I think we're probably 4 years in this one. It comes and goes. There's some Japanese folks who are really excited about it. Hygo out of China is very excited about it. I've actually noticed that when I'm in Asia, that high write volume is considered to be a very important workload. I hear about it more in Asia than I do in other countries. So I guess because they have larger data volumes, I'm not sure. But we're still quite a ways away in terms of having a read-write sharding solution. But I think for data warehouse, where to read only mostly, I think this almost gets us there. So I'm hoping we can get some proof of concept, setups. We can start to look at what this gives us. And the beauty is that it's organic. It comes out of the partition. It comes out of the foreign data wrappers.
Right.
All the trimming, of partitions we just talked about previously works, here too. So if you have a query and it's only going to hit one server, or it's automatically only going to hit that particular shard and not all the shards. So I think it organically flows from the general features we've already implemented.
Yeah, it relates to what I see with my customers when they have a huge amount of data, and I say to them they need to some kind of online archive some of their data in some foreign data wrappers to create some kind of fake shards, because we know that those old data won't be queried with the same frequency as recent data. So, but if they can have several shards and can query them parallelly with some parallelism, it will improve some reports and some very big queries they have. So yeah, I agree. It's an important step into the sharding direction for Postgres.
Yeah, I mean, it's not going to be something you're going to use day one, right? But a lot of people choosing Postgres now want to know that no matter how big their data gets, we have a direction for them. And up till now, I would say we really didn't. There was a sense you had to go to a different type of solution, maybe like a Cassandra or something that was designed to be multi-server. But then you're losing all the Postgres features. And the idea here is that you may not need to leave Postgres to get that kind of scaling.